So this is Nitin Dahad, EE Times, and I'm talking to Elad Alon, who's a CEO and co-founder of Blue Cheetah Analog Design. Hello, Elad. Hello.
Great to see you, Nitin.
We've written about some of or talked to some of your customers, like Bayer and Tenstorrent, but tell us a little about Blue Cheetah.
Yeah, absolutely. So Blue Cheetah has been around for a little bit over 5 years now.
That came out of Berkeley.
Came out of Berkeley, that's correct. So myself and some of my former students were the founders. The genesis of the company was all about essentially improving design efficiency, specifically in the analog mixed signal space. But we've really leveraged that capability and essentially the generator-based design methodologies we developed really to go and address the needs that we're seeing in the Chiplet Interconnect market these days.
Chiplets is a big topic over the last 2 years. I've interviewed a lot of people. The big issue is always around how they're going to work together, interoperability, and as you or somebody said, HBM is a very classic example of that in action.
Yep.
But there's a lot more, and at this show at OCP 24, OCP have launched a marketplace, Open Chiplet Marketplace. You are going to be contributing to that, I think. Just tell us about the whole concept and how it's going to work and what's going to happen.
Yeah, absolutely. No, so it's still obviously early on, and a lot of these things are being developed as we speak right now. But the idea is to really get together all these folks that have, for example, like ourselves, interesting data interconnect solutions, folks that are actually developing real chiplets, that they're looking for ways to kind of plug them together with each other, as well as trying to build some of these standards and infrastructure around it that one would need to know of. Okay, well, yeah, I want to build a new conceptual system and package. What is all the information I need from the different chiplets to be able to actually figure out, can I put them together? What are the requirements?
So it's a good thing.
Yeah, it's absolutely a good thing.
Okay, but beyond that, what's next? So how do you make it work?
Yeah, so in terms of how to make these things work, what we've been sort of saying for a little while now, and we think is really the path that the industry needs to take, is as you pointed out, the way HBM really succeeded is a very concretely defined socket for an HBM part, right?
Yeah.
Everyone knows what that is. Everyone knows what it takes to put it together. I shouldn't say maybe everyone, but there's a generally accepted way to do that.
People who know.
Yeah, people know.
Yeah.
And so we very much have to do kind of the same thing on the logic side of the world, where we say, look, these are the sets of chiplet sockets that have large enough markets by dollars behind them that people can then be incentivized to go and really build chiplets that will fit into those sockets. And once you've defined the sockets, all the interoperability problems have become much more readily addressable, right? Because it's not sort of anything to anything, it's this socket, it is this thing.
Right.
Yeah.
So now you've got 15 customers, I think you said, you're shipping in various process technologies.
Yep.
But what are you seeing as some of the things that you're coming up against which still need to be solved, or things that you're able to work on?
Yeah, absolutely. No. So there's always a tension between just the fact that you have some on-die bus somewhere that you're conceptually disaggregating when you're building chiplets, and you'd really love for the chiplet interface to be sort of free from the perspective of the bandwidth density you're able to achieve. And so the continuing challenge is always, okay, well, so how do we get as close as possible as we can to that, while minimizing the energy, minimizing the latency, minimizing the cost and complexity to the end chiplet design? There's a never-ending set of technical problems for us to solve there.
Okay, and we talked at DAC about your relationship with Tenstorrent and Bayer. Tell us a little bit how that's going.
Yeah, no, absolutely. So I'll start with the Bayer side. So on the Bayer side, what I was just kind of pointing at a moment ago of the fact that, look, there's always some on-die bus that you're starting from, and you're trying to essentially disaggregate across this chiplet interface.
Yeah.
Understanding sort of how you actually design the die-to-die full subsystem along with the bus, and what performance that's going to get you, what optimizations are available. That's really what the collaboration with Bayer has been all about, because at the end of the day, that's what the customers really care about, right? It's not that you intrinsically want 32 gig or a terabit or whatever. You want to know what the performance implication that is on your end SoC.
Sure.
Right, so that's what that has been a really great collaboration that we formed with Bayer to enable people to actually really directly address those types of questions.
Okay.
And with Tenstorrent, obviously they've been a great customer and partner for us. As I think Jim recently quoted, we've really worked together very directly to figure out, what are the types of interfaces that we need to build to actually enable the chiplet systems that they've been developing for their future products.
So how's that going?
It's going great.
What can you tell us?
I can't tell you a whole lot more than that for perhaps obvious reasons, but yeah, no, it's been a great collaboration, and we love working with them.
Well, Elad, thank you very much for that conversation.
Yeah, my pleasure. Thank you so much too.